How's it going? My name is Paul Sohi. I'm an industrial designer. Thank you, Chris, for that amazing opening. My role at Autodesk is a little strange. So we do things like this. For those of you know who Al is from D3D, I thought I would introduce myself this way. There is a running theory that Al and I are in fact the same person from divergent timelines, and he's here to tell me about some cataclysmic event in my life. So I always thought that was a good way to introduce myself. I'm also a fanboy first. I'm in a very privileged position at Autodesk where I get to work with a lot of incredible companies that I've had posters of their brands on the wall, and now I get to help them develop stuff. So I do a lot of stuff like this. This is actually, funnily enough, just in the other room if you want to see it. It's the first ever 3D printed performance prosthetic. It was used at the Rio Paralympic Games with a German cyclist by the name of Denise Schindler. She went on to win a silver and a bronze medal in 2 events that she's never actually medaled in before using this prosthetic. It's also 812 grams, which is 400 grams. I'm sorry, I used the metric system for the Americans in the room. Base 10, get into it, it's awesome. So yeah, it's 812 grams, which is 400 grams lighter than the carbon fiber equivalents. One of the other benefits is that because it's 3D printed using polycarbonate instead of carbon fiber, she's able to perform at peak performance for a lot longer than she would be able to with a carbon fiber prosthetic. I also do other stuff like, I don't know if this clicker is working, there we go. Other stuff like this, which is actually down here on the, it's very noisy, I do apologize. It's down here, and I'm going to talk about it a little bit later. But what is the, there we go. So what is the greatest block to innovation? I would make the argument that it's time. When we work on any product today, the biggest challenge is not how do we innovate? It's how much time have I got to get my product to market? And with the explosion and saturation of startups and entrepreneurs and all the incredible stuff we've seen in the last 10 years, it's not really about whether you're first to market. It's what is your differentiator? How are you better than the competition? And ultimately, it all boils down to time. We all have to get our products to market on time. We have to make sure that we meet the delivery requirements. We have to make sure that our audiences are happy with the stuff that we make. But our ability to innovate is always limited by this. So where does AI come into this? Well, AI is not here to replace anything. Frankly, human beings are still a lot better at most stuff. AI is here to augment our processes. It's to help us make stuff better. I like using this metaphor, so mostly because I love getting stuff in the mail. So if you imagine this is the process of a designer. I have to get from point A to point B. I like to think of this as the first-year student or recent graduate. Okay, I've figured out a workflow. I understand how to design and develop something, and this is the way that I do it. And then over time, as you get better at things and you learn stuff a little bit more, well, you can get faster because you can innovate in small incremental ways, such as, building the Panama Canal. Inherently, the process hasn't changed. You're still doing stuff the same way, and you're limited by you as an individual and the team that you work with. What AI enables us to do is factor in multiple workflows, multiple options, multiple outputs, things that we as human beings are limited by essentially brain time. We know that computers can process stuff faster than we can, so why don't we use that to augment the processes that we have in place? So, for example, what we're looking at here is using the shipping route metaphor. AI can take the process of getting from point A to point B and consider every possible option. So rather than me being boxed in of like, okay, well, this is the way that we do things and we can just keep innovating this, why don't I explore all the other options that are available to me and see what makes the most sense? So how does that fit into an existing process? Well, an existing process looks something a little bit like, something a little bit like this. Depending on the size of your team, the number of people you have, you can explore up to X number of iterations of something, you end up abandoning most of them, and you pick one, maybe two, that you then take to market. What cloud technologies has enabled us to do, and CAD in general, is to create these feedback loops that we can use to produce a product. So we can look at manufacturability, we can look at evaluations, we can simulate and then test and validate and make a better product, but we're still working within that kind of existing workflow. Excuse me. So when you bring AI into the mix, so talking about, for example, Autodesk generative design, what Autodesk generative design enables you to do is explore hundreds, if not thousands, depending of course on how much time you want to spend on it, concepts. The difference between a human-developed concept and an AI-developed concept, though, is that you can go straight to manufacturing with that. So if you're an engineer or you're focusing on a single part in a larger assembly, why not use something like this to help you consolidate those processes and get to a product faster? The best part is, though, that it works in an existing workflow. So you're not inherently changing anything. You're augmenting the processes and you're exploiting the power of something that is better than human beings in certain contexts to help you make a better product. So I want to show you this concept video about how we see AI helping and improving processes. So on this motorcycle, the first thing we have to do is identify what it is that we want the AI to do. In this case, we have areas that we know we need to connect together, and we know that we have obstacle regions, things that we don't want the AI to interfere with. Then when we run it into generative design, we can identify the different manufacturing processes that we want to use, as well as add some constraints, and then output those geometries. And those geometries are ready to go straight out of software if you want to, and you can filter that information down to look at the ones that make the most sense for your particular needs and applications, and then start to look at them in product. Everything I've just said is actually available today, by the way. But what we want to do next and how we see this helping creatives in the future is being able to connect to manufacturability, understanding where in the world you can get things made so that you can bring in stuff like your supply chains to understand how it is that you can make that product faster, as well as getting a preview of the fabrication processes so you can better understand in reality how much something is going to cost before you make it. So in the case of the swing arm, the first thing we would do is run it through a simulation to understand how we're 3D printing it properly, taking it over to CNC milling to make sure that we get the tolerances in the right places so the thing works, and then it's ready to go. So AI ultimately breaks down into a few different categories, and the way that we can use it is really, really interesting, to me at least. So taking something like a shelf bracket, which is not something I think anyone in this room has ever thought about. It's usually just like a little stamped piece of steel in an L shape, like job done, the shelf is the focus. Well, as an industrial designer, I think everything should be interesting. Everything should be cool to look at. In fact, I think the best design advice I ever got came from a guitar teacher, not from university. My guitar teacher, when I was learning to play and I was going out to buy my first guitar, what he told me was, don't just buy the guitar that feels good to play. Buy the guitar that every time you see it on the shelf, you want to pick it up and play it. So it's got to work, it's got to be able to be a guitar and feel really great to play, but every time I look at it, I want to be excited to use that thing. And I think that applies to all good design, including something as mundane as a shelf bracket. Well, what AI has enabled me to do here is take loading conditions, because ultimately a shelf bracket is a structural object, but I want it to be beautiful, produce an output that really there's only one way to produce, which is 3D printing. But I got that back in 20 to 30 minutes. So if I'm a designer and I know that I have to pump out a bunch of sketches or I want to explore an idea, rather than just going forward with this assumption of like, okay, well, I'm going to do this and then throw it over the fence to the engineers and they'll figure out how to make it work, that isn't the way we work anymore. In fact, that hasn't been the way that we've worked for a very long time. The lines are starting to blur. So why not take this structural information and use it to inform actual design. So I know where it is that I need to put material. I know where it is that things are structurally critical. So why not design around that? So what you're looking at here are 3 different examples of that shelf bracket with reduced levels of complexity, which is sort of inversely proportional to manufacturability, I guess. So in this case, like taking a 3D printed design and making it a little bit simpler, then simplifying that state a little bit more so we can use more traditional processes, and eventually on the far right, getting to a design that's just using sheet metal. And in context, that's what they all look like together. So that's just one element of it, is design. Obviously, strategy is a really significant part too. And I think what's really interesting and exciting about AI's promise for creatives is reconsidering how we think about stuff. So that's the swing arm. That's the way it was designed. That's the way that the CAD model was made. And specifically, we're looking at this. So instead of looking at objects as the finished version in our heads, why aren't we working from abstractions? If AI is helping me to understand where I do and don't need material to inform design or to inform engineering, why give it a finished thing? Why not just tell it what it is I'm trying to do? So that's where that preserved geometry comes in. So that's the only thing that's relevant to me. I don't need to worry about the rest of what the swing arm looks like because this is where I need stuff to get together. So I'm starting to emaciate my model. Obviously, this now turns things on its head a little bit. So as a designer, I'm not interested in the stuff around it. I'm actually modeling the negative space. So for the case of a swing arm, which is actually kind of a complex part, it's not just a single static element. It's part of a larger assembly. There's a lot going on. A motorcycle's got to bounce and deal with the road. The thing that you end up modeling is actually more like this. So what I'm interested in now is what do I have to connect to? How can I get a tool into that? How do I deal with motion? And rather than having to make life really, really complicated for myself, I can accelerate my process and end up with a finished product. This is Lightning Motorcycles, the world's fastest electric bike, commercially available today, and that's the swing arm. Anything to help the performance obviously is important. But that's not the only part of it. So there's execution too. Obviously, you need to make sure that stuff works properly, and that you can get something that's desirable. So I was tasked with a project a few months ago. Someone came to me and said, everyone thinks 3D printing kind of sucks. It depends. I'm like, well, hang on. What do you mean by that? Like, it's kind of awesome. Like, well, it's fragile, and it just breaks all the time, and no one wants to use it because it's expensive, blah, 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 blah. It went on and on and on and on. And I'm like, okay, first of all, not true. Second of all, I bet you, so this kind of came out of a gamble. It's like, I bet you I can 3D print something and design and make it in less than a week and put it through one of the most extreme testing environments I can think of, and it won't break. That person still owes me $10, by the way. So I went with a skate truck. Skateboarding as an industry hasn't been innovated on in over 40 years. You probably haven't thought about skateboarding until I just brought it up. It's not even cool anymore. It was when I was a kid, but they're all into vaping now? I don't know. So this is what I designed, and I showed this to my colleague. I'm like, I'm going to turn this into something really incredible. And what I really love about this process is that I get to focus on the stuff that matters. So when I'm designing something, I'm designing, obviously, as a designer, I want to empathize, but I also want to make something that's functional. Now I can take those two elements and really, really focus in on them. So with a skateboard, I have to think about how that thing is used. So it ultimately breaks down into sort of 4 scenarios. I'm going in a straight line, I'm leaning left, I'm leaning right, or I'm landing and there's a sudden impact on the board. So I designed the negative space. What you're looking at is a motion envelope that I talked about, a tool access so that I can tighten the board down, and then the wheels. And then I put that into generative design. It gives me the results. So there's some in here that work really, really well, and others in here where I was doing material exploration. I was like, I wonder if I could use just aluminium, 6061. And that one in the top right corner looks like it had an allergic reaction because, well, frankly, that's what it would have to look like to deal with the situation. So again, for someone like myself who hasn't got an engineering background, but I want to make sure that I can make my product get to market faster, this is really helpful. I'm like, all right, aluminium's out the window. That's not going to work. And then I selected the result that I wanted, and this was the test. We did that about 8 times. We then took it to a skate park with 8 professional skaters, and we just laid them a challenge. I'm like, I dare you to break this. And we specifically picked the skate company that we went with, Braille Skateboarding, if you're interested in looking at it, because people send them stuff all the time. They have a series called You Make It, We Skate It. Over 90% of the things that people have sent them, they've broken. And these are all either just hobbyists, individuals, innovators, startups who want to show their product off to the market. They've broken it all. And this is the one that we gave them. It's going to be kind of hard for those of you in the back to see this. This went through 12 hours of grinding. That's not 12 hours of like just in the day. I mean, there's 12 hours of someone grinding on these. And they're fine. They've been slammed on hundreds of times. They've taken it off a 12 or a 14-foot drop. There you go, Americans. And about 5 or 6 times, it's survived everything. The best part is, for a skateboarder, they're also 45% lighter. And what does that mean? Oh, that's not going to work. It means this. This was actually the first thing they tried with the board, and he wasn't intending to double flip it, but it just did. So we were left with this understanding of, well, of course, we made it 45% lighter. It makes perfect sense that it's going to double flip. Now, is this the future of skateboarding? No, probably not, because 3D printing is still kind of expensive. But the point is, it survived. Additive manufacturing is not weak. And this wouldn't have really been possible without AI at the core of it. So as a takeaway, what we did with this project, we took a board and we made it 45% lighter. It's 8 times as durable compared to the standard aluminum used in casted trucks. And we're actually going to make these considerably more affordable by casting them. So 3D printing, of course, for anyone wondering, these are $1,300 each. So like I said, it's not really practical for skateboarding yet, but as a proof of concept to demonstrate that the technology is incredibly strong and that there is some promise here, is really incredible. The last thing I want to leave you with, which is up there on the slide, anyone who's built anything, doesn't matter what it is, knows that making real stuff, physical stuff, takes a really, really, really long time. It's kind of painful. That's why students cry a lot. I mean, it probably helped Kleenex stocks go up just from the number of tissues I was using when I was a student. But we went from start to finish in 3 weeks. And that's including the time it took to film the video and fly out and do all that stuff. I don't know of anything that you can make that fast. So that's the future of AI, hopefully. Thank you.